We build drones like the one in the background, and we use these drones for marine monitoring. And when you get a satellite image of a boat, you get like a few black pixels or a few white pixels, but you don't know who that is. You can't do anything about it. So it just, all of this illustrates, we know nothing about happening out at sea. People profit from that by doing, weapons trafficking, drug trafficking, pollution, illegal fishing. If you want to monitor the sea, you don't necessarily want to be like, panning left and right and deciding where to look. You want to collect imagery about everything and then do the processing. So what we have on this drone instead is an array of different cameras that point in different angles. They don't look forward or backwards. They just look sideways, a little bit like a satellite actually. And because you fly very fast, it doesn't matter. You're just collecting the imagery.
Could you just, at a surface level, let us know what goes into building an effective drone?
It's a bit like, you have planes and helicopters, right? Which are two ways to be airborne with like a motor. And for drones, like that very broad category of drones, you also have that you have fixed wing. So like look like plane. And then you have the quadcopters, multi-rotors that have like motors that's what makes you airborne rather than the wing. Two very different types of benefits. If you have a wing, it's way more aerodynamically effective, so you tend to have like lower energy consumption for the amount of mass you're moving and the distance. But the downside of a plane is that you need a runway or you need a catapult or something to make it take off. And then the quadcopter, more like multi-rotor type of thing, which is typically what people imagine as drones, the one you can buy off the shelf. These don't fly for very long at all, but they're very convenient to use because they don't need a runway and they're very easy to operate.
Are you familiar with this risk of drones getting hacked by some nefarious actors?
Yeah, there's plenty of ways you can hack a drone. Even like large military drones have been hacked in the past. Something as simple as the spoofing GPS. You can spoof that signal such that your drone is being misled to believe it's somewhere else.
People who are anti-drones, they claim that drones are risks to larger aircraft in the sky. They could get sucked into plane engines and things like that. Is it something your company or you're worried about?
There's plenty of things that we can buy that can be used in a nefarious fashion. Like drones are no different in that aspect. It captures our imagination more because you can't go drive your car into an airplane, right? But you could do that with a drone, which is way more dramatic. Like we have people on our team that are like doing the same job as someone with a master's and they haven't gone to university at all. And that's because specifically in our space, in the drone space, it's a very young industry and you can very quickly pick stuff up about the industry by spending the weekend building a drone. Like you can buy an autopilot nowadays for probably like 10, 15 pounds. You can buy the parts to build your own drone.
What would you say to people who claim drones are here to steal away the jobs for humans? Illegal fishing, drug trafficking, oil spills, and human trafficking are but a few of the illicit activities that flourish unchecked across our oceans, largely due to the challenges of monitoring and surveillance. Our guest today is on a mission to overcome these challenges via the use of drone technology. Mathieu Johnsson is the founder of Marble, a developer of some of the best maritime monitoring drones you would find anywhere in the world. Welcome, Mathieu. How are you today?
I'm good, Newton. Thanks for having me. Really excited for this discussion.
Likewise, a pleasure. Mathieu, do you mind telling our audience, first of all, who you are briefly, and then also what you do in the tech space? Just a surface level introduction, please.
Yeah, sure. I'm Matt. I'm the founder and CEO of Marble. As you've said, we build drones like the one in the background, and we use these drones for marine monitoring. Me specifically, I come from a family of graphic designers, but also plane pilots. So I've always been in and around planes since I was very young, and so I kind of got very passionate about this from an early age, and started dreaming about designing planes as a job, and so I studied aerospace engineering, and then ultimately went to Airbus, the big aircraft manufacturer, to be in their secret office, the one that does planes that might come up 20 or 30 years from now. And I joined that team and pretty quickly realized that actually working on planes that are so slow to develop is actually not the most exciting thing. And that instead I thought it would be way more interesting to push for new technologies in, electrification, automation, new manufacturing method. It would be way more interesting to work on this at a small scale where you can iterate faster and make more of an impact, which is why I ultimately left Airbus and I started Marble, where we work on very exciting drone technologies and we apply them for a very interesting problem, which is marine monitoring.
Well, interesting. We're going to dissect a lot of that shortly. Just so I understand, and maybe for the audience, you're tuning in from which part of the world? Is that France?
I am French, but I've been in the UK for 12 years now. And the company it's a British company, and I'm actually in the process of getting my citizenship. So I'm turning in from Bristol in the UK.
Oh, just nearby. Okay, nice. Okay, just maybe we start from the basics. This whole concept and this field of maritime monitoring, could you tell us just a little bit about it? What's all of that all about? I'm sure I speak for some in the audience who are not really well versed with what happens in this particular domain of work.
Yeah. So maybe I think an interesting perspective is just monitoring in general, because I think we all have that kind of false assumption that governments and organizations have a good understanding of what's happening on the planet and that most activities are monitored. And I think we have that false impression of people, like governments know what's happening because you go on Google Maps and there is a high resolution image of your street and everything. And so based on that, we kind of assume that satellite is so powerful that basically you can see the whole planet at all time very easily, right? But that's actually not the case at all. Like if you look at Google Maps data, it's actually not satellite, it's planes. Google pays for people to fly planes to take photos, either straight down or sideways. And by using, a combination of straight down and sideways, you can even reconstruct 3D in so in the UK, for example, in populated cities like Bristol and London, everything's in 3D. But then if you go further out, like in the ocean or like some remote parts of the world, you clearly see that the resolution goes down, right? If you go check those places, it's not the same resolution everywhere. And that's where you actually end up with satellite imagery. And I think that just illustrates, satellite imagery isn't super good. And we tend to think it is just because we have that false perspective from Google Maps in cities where, again, it's plane photos. And you can imagine those plane photos, they get taken maybe once a year, maybe every 6 months if it's an area that is very, very in demand for Google. But the rest of it, it's for satellite, it's like very infrequent. And let me tell you another thing about satellite is that if you yourself were like, let's say you work for government and you're like, okay, I need imagery for that area where maybe there are some oil rigs and I want to monitor the area or whatever. You need to order that image weeks in advance before the satellite comes by, and you will get the photo a few days after. So it's not like you just tune in and it's like, hey, I want real-time images from this area. So you can imagine that I'm just giving that background because I think as citizens, we have a misconception of how well the planet is monitored and how much we know about it. So Google Maps is images from planes mostly, and it's done very regularly. So it's not like government or organizations don't have access to that. And now you can imagine, obviously Google Maps is only for overland because they don't go above the sea, because nobody, you don't really care about having high resolution images of the waves and things. Nobody is interested in that. But from what I've just described, it kind of gives you that understanding that we don't know what's happening even above land in areas where there's high population density. So you can imagine at sea, nobody knows what's happening out at sea. And it's still that Wild West, which means if you are someone who is malevolent and you want to do something illegal, you just go out at sea and nobody's ever going to know about what you're doing. Which is why you have most African countries, they have their fish population that are being completely decimated by other countries that go fishing in their seas because nobody knows about it. At best, you have satellite imagery that at sea, satellite imagery will pick up a really, really large boat, 40, 50, 100 meters, but anything small won't get picked up. So, and when you get a satellite image of a boat, you get a few black pixels or a few white pixels, but you don't know who that is. You can't do anything about it. So it just, all of this illustrates, we know nothing about happening out at sea. People profit from that by doing, weapons trafficking, drug trafficking, pollution, illegal fishing. But there's also tons of problems with like environmental concerns as well that we can't track. Like, for example, sargassum is a seaweed that is now growing exponentially in the Atlantic because of warmer waters due to global warming. And we can't monitor that because we don't have the tools to do it. So that's kind of the problem. We don't know what's happening out at sea. We have tools to do it, which would be, I said Google is flying planes to take photos of cities. So sure, we could just play for like millions of planes to be flying all the time, taking photos of the whole surface of the world, but that would be ridiculous. So that's kind of like what we're trying to solve. We're trying to make that happen, have planes flying continuously everywhere to monitor, but obviously with small aircraft that are cheaper to manufacture, cheaper to operate, you don't need a pilot on board. They have much better sensors that are bespoke to monitor the sea. And if you put all of that together, you can do something like, 1,000 times better than what exists today because people haven't looked at that problem enough so far.
That's fascinating. But how does one even get started? How did you just get interested all of a sudden about monitoring oceans? I mean, I'm sure not many people wake up and think that is a mission, that's something they could achieve.
The origin of the company wasn't maritime monitoring. My story was one of passionate about aerospace and wanting to, like seeing all those new technologies of electrification, electric cars, autonomous cars, all these things, and kind of like saying, okay, how can we do more of that in the aerospace world? And that's how I started the company. I was interested in that aspect, and I could see drones could be made like way better than what exists today. So that's why I started it without a particular application in mind. But obviously you don't have a business just like building cool planes. So pretty quickly I figured out the best application is marine monitoring. And that's when I kind of like, I a bit randomly ended up on marine monitoring, to be fair. It happened because I have a good friend in the Caribbean whom one day we were talking about what we were doing and kind of realized in the Caribbean, most countries don't have large resources, right? So most of the countries in the Caribbean, they don't have an air force with planes that can monitor the sea and see what's happening, which means that those Caribbean countries, they are very, very subject to that problem I mentioned earlier, that we don't know what's happening out at sea. And if you're a Caribbean country that has drug trafficking, weapon trafficking, you're very, very impacted by the fact that you don't know what's happening in your water. You can imagine you're an island that has like an archipelago of 40 islands. Some of them, nobody lives there. How do you know what's happening there? How do you know that people are not like getting up to no good, right? So it started from this and realizing, wow, there are countries here that don't have planes, don't have like any way of monitoring. And that was the problem on one side. And then on the other side was my understanding of what we could do with drone technology today if we were putting our effort into it. And that's how I came up with the intersection of those two things. And then, ultimately you build up on that. And then what we realized is drones are difficult to operate today because of regulations. Because you can imagine it's a bit like autonomous cars. You're not allowed to just get in your car and get your hands off your wheel, right? You even though the technology is almost there, you still have regulation that stop you from doing this because it's not well understood, what could be the impact, right? But drones are the same. You don't have, but the difference with the drone is you don't have a pilot on board that can have the hands on the wheel or not, right? You just have nobody inside the drone. So the way it works now is that you're only allowed to use your drone in areas where it's deemed safe enough. So it's a bit like you had an autonomous car and you were said, okay, you can go in your autonomous car and and do nothing, just not have a driver, but you can only do that on a track, not on the road. Drones are kind of like that. And now you can imagine flying above water because nobody is there, or mostly nobody is there. It is much safer and it is easier to convince the authorities to say, okay, give us permits to fly those drones in large numbers far out to sea, and that will be safe. And so that's one of the big reasons why we do marine monitoring, is because being early in this industry, it is one of the most favorable environments to develop the technology. When I was in Airbus working on those big aircraft, they all are internal combustion engine. They're not electric because it's very, very difficult to make large airplanes electric. And that's one of my frustration is when I said I wanted to build new planes, I want to build new planes that don't have carbon emissions, that are electric. Yeah. All of our drones are electric. So there is clearly and actually the name Marble, that comes from one of the first few photos that was taken of the Earth from space. It was like a very famous photo because, you can imagine, like when we used to not have these photos, and when they came up, it was like a big event. And so it was named the Blue Marble. That's the name of the photo. And when this photo came out, it was used a lot in environmental circles as, oh, look at that small planet, like in that black background, like we're so small and we need to look after the planet. And so that's why the company name is Marble, and the logo is like a little crescent. That is because we only do electric aircraft. We build them to do marine monitoring, and so there's clearly that sustainability aspect is essential.
Okay, we're going to circle back to the drone aspect of this shortly, but just want to help our audience understand a little bit about your career. We wouldn't spend too much time on that, if you don't mind. I just want to poke in there just a little bit. How was your career in tech just before you got this company up and running? Did you go the typical route? You had a technical study, went to university, studied something, computer science or something like that? Could you just briefly walk us through how that looked like?
So I studied engineering in France, very general engineering, very little software engineering. Actually, I was, I think, mostly like math, physics, and mechanical engineering. And then when I moved to the UK, I did some further studies specifically in aerospace, in aircraft design. And yeah, so I got those masters, and I think that gave me a very good foundation on understanding things from first principles.
The masters you had in aerospace, what was that called? I'm trying to get our audience to know what someone studies in university to further such a career.
It was called so the university is a postgraduate only university called Cranfield, and it was called Aerospace Vehicle Design.
Vehicle Design. Okay.
Yeah. So again, like for fundamental understanding of physics and things, that was very useful. But I would say because the drone space is still pretty immature, what matters is, are you good at prototyping? Have you built drone yourself? Can you solder? Can you build things with your hand? It's still very much that stage for the drone industry. If you want to be good at it, you just have to spend the weekend building drones by yourself. There's nothing stopping you.
But where do you go to learn? Where do you go to learn
online?
To build drones?
You will get a much better drone education from just prototyping and being a hobbyist that just, goes to a club and learn with other people or read on forums online and try to do your own thing than you would by going to university.
Interesting.
It just makes sense. Like the way university works is they get told by industry, we need those skills, give us more people with those skills, and then they build a curriculum and then ultimately train people, and then those people come out. But you can imagine there's a large delay between those elements, right? First, you need the industry to be able to say, hey, this is what we need in large numbers, and then ultimately the curriculum gets written, and all that stuff takes a while. Right now, the industry, most people in the industry don't even know what drones are going to look like in the future, and they're probably going to look very different to what they look like today. So how would you know what type of engineer you're going to need to be able to do that? So if you want to be at the forefront of the drone space, you just need to be the one experimenting and building things yourself, which is probably like 5-10 years ahead of where university is at.
Interesting. No, that's a useful piece of information there. And now back to the drones. If you don't mind, could you just, at the surface level, let us know what goes into building an effective drone? I'm not asking for a full-blown lecture, but I think it would help just how aircraft like this, if drones actually qualify as aircraft, they're quite tiny. What goes into building them?
So you're talking about like drones like ours, not like the smaller ones.
No, like yours. I don't know if there are now categories of drones. You've got me a little bit confused there.
Yeah, the category, it's weird. The vocabulary, it's changing constantly. So that's what I was asking to clarify. So, the main thing is it's a bit like, you have planes and helicopters, right? Which are two ways to be airborne with like a motor. And for drones, like that very broad category of drones, you also have you have fixed wing, so like look like plane, and then you have the quadcopters, multi-rotors that have like motors that's what makes you airborne rather than the wing. Two very different types of benefits. If you have a wing, it's way more aerodynamically effective, so you tend to have like lower energy consumption for the amount of mass and distance the amount of mass you're moving and the distance. But the downside of a plane is that you need a runway or you need a catapult or something to make it take off. And then the quadcopter, like multi-rotor type of thing, which is typically what people imagine as drones, the one you can buy off the shelf. These don't fly for very long at all, but they're very convenient to use because they don't need a runway and they're very easy to operate. I think going forward in the future, most drones will be those two features overlaid, and you can see ours. You have those 4 propellers that are for vertically taking off and landing, and then you can see obviously the wing to get the benefit afterwards.
Looks pretty big, right? Compared to the drones I see flying around my neighborhood.
It is quite a bit bigger than the one you buy off the shelf, but it is much smaller than the one you would typically see in governmental use or military use, because these ones are going to be like 500 kilos, 7-8 meter, so much bigger. This is pretty small. But yeah, you will in the future, drones are going to be mostly those two things overlaid on top of each other, where you take off vertically like a helicopter, and then you have a propulsion that makes you accelerate, and as you accelerate, those quadcopter motors turn off, and then you're just like flying like a plane. There's multiple benefits to this, but yeah, going forward, that's what it's mostly going to be like. We've done this and have pushed it to the extreme where our drone's actually really fast. It flies 100 miles an hour, which for drones that size is actually like pretty remarkable. And that just gives us big advantages, because when you want to survey a large area, being able to go quickly is very important. And yeah, so I'd say that's like the fundamentals of how I think drones going forward are going to be like.
Trying to gauge how your drones differ, in essence, from the regular drones we have around. You've just mentioned speed, so it's pretty fast, 100 miles per hour. That's quite fast.
Yeah.
Any other distinguishing features about your drones you'd like to share compared to the drones we have that are delivering parcels and pizza these days?
Yeah, I mean, so most of these drones, whether you buy them off the shelf or the delivery one, they typically fly, like 10, 15 miles or something, which is fine if you want to do logistics. It's like a bit like what the range you would do if you were ordering on Deliveroo with like a cyclist or someone on a moped. It's just a few miles. That's fine. If you want to monitor the seas, obviously you need to go much further. So that's kind of like what we've done is a small drone that flies very fast and can go very far. So this can do today 100 miles an hour of speed, and it can travel 100 miles. So 100 does that in an hour. The other element to our drone specifically is the sensor we have on board. I don't know if you have flown some of those toy drones, but typically the toy one you can buy off the shelf. Once they're airborne, you have control of the camera, which means you can tilt left and right and pan, and like you can see where you look. That's how they're designed. Most drones are still designed this way. What we've done is very different, because if you want to monitor the sea, you don't necessarily want to be like panning left and right and deciding where to look. You want to collect imagery about everything and then do the processing. So what we have on this drone instead is an array of different cameras that point in different angles. They don't look forward or backwards, they just look sideways, a little bit like a satellite actually. And because you fly very fast, it doesn't matter. You're just collecting the imageries. Imagine like just again looking sideways, and as you move forward, you scan a large area. So from the ground up, we designed the drone really just to do that. And again, it's a combination of very high-speed drone and those sensors that merge into being able to scan a very, very large area.
Interesting. And I'm sure there's some form of you don't have to share some secret about the technology, but I guess there's some form of pinging back to a central controlling dashboard back at the deck somewhere, because this monitoring is real time, right? It's live. So does it needs to ping back in real time? Can someone actually see what currently exists at a particular spot on the ocean in real time?
So you do need to have a real-time connection for regulations, because you can't just go send the drone and say, oh yeah, it's fine, we don't know where it is, it's doing its thing, and eventually it will come back. You need to know at all time, its position, the health of its system, and all these things. So we have all of that, but the drone, and we can at any point take over control if needed, because that's an important regulatory point. But the drone itself, otherwise, from takeoff to landing, can do everything itself. So it does its takeoff, it does its transition to wing-borne cruise, and then follows waypoints, and then comes back. And all the data that the drone collects in real time, we get it sent it directly to our servers. And then there's a little bit of processing, which might add, a little bit of delay, like a latency of a second or so. And then on our servers, this gets reconstructed in real time, so you get the map built. So a little bit like, if you were flying above a city, and imagine like I don't know if you play video games where, you have like a fog of war when you're on the map and you start a video game, you don't really see necessarily the whole map because you haven't explored it yet. So everything is grayed out. It's the same for us. And it's like as the drone moves, it kind of like appears as you collect the imagery. And yeah, all of that happens in real time. So you could be in your office somewhere and you just log in and you can see the images get collected in real time. And it's just not limited to one drone, by the way. If someone wants to have, very frequent and very large scale monitoring, you can just have 10 drones flying at the same time. Like that's not really much of a problem. So you can really scale that up as much as you want.
Interesting. Are you familiar with this risk of drones getting hacked by some nefarious actors and then using that now to harm people? Because I know there was this company, I can't recall the name, it's a drone manufacturing company. They proved to the public that a drone can actually be hacked and used to perform some illicit activities. They actually went to a park, flew the drone over some public park, enabled some Wi-Fi, and whoever connected to that Wi-Fi was pretty much hacked. Are you aware of this, and is your company taking some measures against this?
So I don't know that specific example, so I'm not sure like the specific technicalities of what happened. But yeah, I mean, there's plenty of ways you can hack a drone. Even like large military drones have been hacked in the past. Something as simple as the spoofing GPS. So the way when the drone flies itself, it doesn't do that based on recognizing the land and making decision based on, I can recognize this feature or like this mountain, so now I know I need to turn left, right? The drone just does it based on GPS. So if basically the GPS tells it, you're here now, and then the drone can decide, okay, so I need to go to the next point, and that's the only source of information it uses traditionally. And so if you can spoof that GPS, which you can do by just like GPS is you can imagine a drone is receiving a signal from a satellite that is quite far out. So those signals are pretty weak. You can spoof that signal such that your drone is being misled to believe it's somewhere else. And so if you can make believe a drone it's somewhere else than where it actually is, then you can force it to behave in a different way. And there has been in the past militaries that have been led to land in an area where they weren't never intending to land there, but because the GPS had been spoofed. But something like this is actually quite advanced, and that's more something that would cost a lot of money to do, and you would want to do on a very, very large aircraft. If we have like hundreds of drones like ours, and it's not going to be an illegal fisherman that is going to have the means to do this. It's way more complex. I think a more straightforward way is as you said, hacking the communication system. But there's plenty of methods nowadays that have just encryption. So if you don't, some toy drones use Wi-Fi, and I don't know, the example you mentioned, maybe there are pretty straightforward ways to hack that. But the norms in commercial drones nowadays, it's all encrypted and it's pretty difficult to get into. So it's not something we worry about. And the other thing is our drones themselves anyway are they're not weaponized. They're 10 kilos. Sure, they fly fast, but they're not extremely dangerous by themselves. So I'm not sure how much of a benefit would there be to hack them.
Yeah, they are not weapons of tactical warfare, or at least not yet.
No.
Yeah.
We're not building that.
Great explanation there, and thanks for that. Just trying to, there will be some people who also, I know I have seen this online as well. Some of those people who are anti-drones, they claim that drones are risks to larger aircraft in the sky. They could get sucked into plane engines and things like that. Is it something your company or you're worried about? Could you weigh in on this, if you don't mind?
I mean, it's in general, for sure, you don't want to encounter another airplane and damage it. That would just... we haven't had yet a proper incident. There hasn't been, like a airliner or I don't think there's been a fatality in someone in a plane from the plane colliding with a drone.
I assume they don't fly at the same altitude, right? Or do they?
Yes, yeah. I mean, they shouldn't. But I mean, just to get back to your point, like there hasn't been an accident like this, but I can imagine if there was to be an accident like that, it would be very detrimental to the whole industry, which we're trying to build. So we're doing it. I come from an aerospace background, like in Airbus, in large companies where that safety for large airplanes is always the priority. And I think the whole aerospace culture is very much safety centered, and we have kept that same culture. So it's very important to us to make sure that we operate our drone in a way that we definitely don't endanger anyone else, whether it's someone on the ground, it's someone in another airplane. But to be fair, it's kind of it's the whole industry needs to figure out how we make that happen. So maybe, I mean, today you could buy a drone and you could go and try to crash it in another airplane. Like the technology doesn't stop you from doing that. Unfortunately, most people aren't bad actors and trying to do this. But I mean, when I say this, you could also say, just buy a car and go crash your car into someone, or like there's plenty of things that we can buy that can be used in a nefarious fashion. Like drones are no different in that aspect. It's just it captures our imagination more, because you can't go drive your car into an airplane, right? But you could do that with a drone, which is way more dramatic. So yeah, that's why I'm like, as a company, what we're doing is we're engaging with regulators so that we can create the rules so that drones can fly closer to large airplanes. Because right now you said that we fly at different altitudes. That's how it works. Drones fly one way in an area where they're far out from everything else. If you're a proper operator and not someone who is like not following the rules, you fly far away from everyone, from all the other airspace users, and then the large planes are somewhere else. But we need to be able to integrate these two types together closer, so that a bit like, autonomous cars, you want autonomous cars to use the same roads as the regular cars. You don't want to build a secondary highway just for the autonomous cars. And I think for drones, the same. We don't want to long-term have those things separated. And it's just going to take a while, because those regulations, again, like for autonomous cars, they're difficult to set up. But I think it's inevitable that we'll find a way.
I'm guessing at least there should be some ways for these drones you're manufacturing to be able to sense physical objects in their proximity, so to say. Because, I mean, there has to be, right? The drones are not just sent out to fly over a certain area of land. And as you said, they are kind of guided via GPS. I would think, out there in the wild, GPS alone could take them directly to crash into some low-flying helicopter or something. Is there any technology that's doing that? Or right now it's still too early to have that technology?
No, it's a very good point. So you do have the technology today. It's just not yet accepted as a good mean to ensure that it's not accepted yet to be good enough so that you are allowed to fly next to an airplane. So it's like what you were talking about. Maybe it's having cameras on the drone, or actually there is
because are these drones really flying at 100 miles per hour with just GPS guidance?
Yeah. But the issue, if we're
can the GPS, for example, spot another large, let's say a ship that's in its path, right? There should be a way for it not to collide with that ship, right?
So I mean, in general, ships, like, we fly high enough that we're never going to be in proximity to ships. But for other planes, it's not easy to know where other things are. So if you imagine, actually, maybe what's interesting is understanding how the airspace works today. You can imagine where, like, I don't know, 100 years ago, when planes started, like, things started being in the air and we had to figure out how to not crash into each other. The assumption was always whatever is in the air always has a human on board, and basically the fundamental rule became there is always someone in the plane, so you can assume that the people will see each other and they will avoid each other. And so that's how it works in a type of rule called like VFR, which is like visual flight rules. That means you can see other people. And so in that case, it's fine to just trust that people will see each other and not crash into each other. That's how it works for hot air balloons, gliders, people that are in paramotors, parachutes, small airplanes. Now you can imagine if you want to fly in the fog, what I've just said is not going to work, because you're not going to see other planes in the fog, right? Still, when you go onto a British Airways flight or whatever, they don't close the airport because there's fog, right? The plane still takes off. And so what happened in those cases is you have instrument flight rules, in which case all the planes, to be able to fly in the fog, you need to have a plane that has something that broadcasts its position. That broadcasting of position, the control tower can see it, and because all the planes are doing that broadcasting, then you can make sure nobody crashes into each other. And at that point, the responsibility is not really the pilot to see others, it's the control tower to manage the air traffic. That's kind of like how it works today. Now, if you're a drone, you're typically, you're not, either you want to fly in the fog with the big planes, but you can imagine the system that are on these planes, they cost like millions. So you can't really put them on small aircraft. It's way too expensive today. So in general, planes, unless you're talking big military stuff, they don't fly with the big airlines, the big planes and in the fog and everything. Drones typically fly with the hot air balloons, the small aircraft and the gliders and all that stuff, only when you see each other. Problem with the drone is the drone can't see the other users because you don't have a good computer vision system, or even if there was, it's not yet accepted as being good enough, same as with an autonomous car. And so today for drones, you need to be a pilot on the ground that sees the drone, and because of that can make sure the drone is not going to crash into a hot air balloon. So maybe the pilot's not on board the drone, but it still sees the drone at all time. That's the requirement, and that's how, to get back to your point, you make sure you don't crash into someone else, is that you should always see your drone. And that's how you make sure you can't hit someone else. That's the fundamental rules. Now you can imagine for us where we want to fly out at sea, we need to fly further than where we can see the drone. Otherwise, we're not going to monitor anything, right? So in that case, we are completely flying blind. The drone flies in an area where we don't actually know whether it's going to hit something today. That's how it works today. That's why we have specific permits where we fly in areas like at sea where nobody else is allowed to fly. And that's how it's safe. It's like if you are in that airspace with your hot air balloon or something, you actually shouldn't be there. It's forbidden and people don't go in those areas. It's typically an area for military exercise or these types of things. And interestingly, a lot of coastal areas worldwide are military exercise areas because nobody goes to fly low level above water. And you can imagine the armies, they need areas to be able to practice their drills and things, and typically it's at sea. So basically where we fly is typically because the military owns those areas, or like they have primary rights to, fly in those areas. And we can just ask, hey, you're not training now, can we just fly? And most of the time they are not training. So we can use that airspace most of the time. That's how it works today. Long term, what I suspect, and what most people in the industry believe, is that what you have for large airplanes that fly in the fog, where basically they all have a transponder that says, hey, I'm here, this is my altitude, this is the type of aircraft, blah, blah, blah. You will have all drones that have this, and also the hot air balloon and the small planes, everyone in the airspace will have that, and everyone can talk to each other and make sure they don't crash into each other. But that's going to take a while to implement because that's a big change, and it's gonna take a while. But all of these things are happening slowly in the background. It's probably gonna take 5-10 more years to be fully implemented. But that's why we're doing maritime monitoring, because it allows us to bypass all of this because we fly somewhere where we don't have other airspace users.
Yeah, no,
that was a deep dive. Sorry.
And very much needed as well, because I'm sure it must be concerning for more than a few who are hearing this for the first time. One more concern, if you would permit me to share about drones, which I know the public tends to have today. It's quite a popular one. What would you say to people who claim drones are here to steal away the jobs for humans? Especially delivery drones, but your drones as well, I guess some humans could actually be sent out to sea to help monitoring rather than flying an inanimate object to go do that. What would you say to these people?
So I'll answer logistics maybe afterwards, and I don't know much about that, but it's mostly for marine monitoring. Like, it's actually one of those typical roles that robotics, there's only positives, because you don't want. We've talked to people that are sent on ships to go monitor something, and they hate it because it's very dangerous to be out to sea in bad weather. It's very, very slow. It's very, very expensive because, like a big boat with like 4 or 5 people on board, like it's very expensive to run. Can imagine, again, dangerous for people. And why would you send people to just do monitoring when you don't know if there's something to be done. Like you want to send people, if you, let's say you have a boat with 10 staff on board that are super qualified, and you want to use them when there is a boat sinking so that you can go and recover the people that are from the vessel that is currently sinking, and you want to save them. If that boat that you have with 10 staff on board has been used every day of the year, like 24 hours a day, to just go and monitor just in case, and nothing was happening for 99% of the days, in what state do you think they're going to be in when they actually need to go out to save someone? It's much better if you have the drone that does that job, that does it much better because we go faster, go a larger area and everything. And then those people on board the vessel get that data, and then they can go out when it's needed. One of the best example is we were talking to a Caribbean country where the way they do their monitoring against like drug trafficking, for example, is they have a radar. And I don't know if you've ever seen, like in movies, the way it works for a radar, but it's like you just get dots on a map. It doesn't tell you what it is. It just says, hey, here is a dot. Typically, those radars will have 10 dots a day, maybe. That could, they will have way more dots than this, but the operator of the radar will say, hey, here are 10 dots that I don't know what they are. Like, I can't tell you what they are. They just look suspicious, and I don't know what it is. In that case, the Caribbean country will send a boat to 10 of these dots to just go figure out what it is. And 99% of the time, it's nothing. So the staff on these boats, they're like, why do you keep sending me to do this thing? It's just like pointless. I'm wasting my time. And they actually love the idea that for those 10 dots, they don't need to go. We just send the drone. The drone gets the data and say, hey, here is actually something of interest. You should go. And then they go with their like full of energy. They have saved the cost of wasting fuel and things. So in the case of maritime monitoring, I think there's, if anything, we're going to create new jobs because we're going to give data about like what's happening out at sea. There's probably going to be new economic opportunities for, being better about like being better with fishing, being better to like grow crops of seaweed, for example, which can create new jobs. If you're talking about delivery, it's a bit different for that. And I, to be fair, I don't know that much because that's not the field we're looking after. But I suspect drone delivery is going to remain relatively niche. I don't think it's going to completely replace the way we do deliveries today.
Well, who knows? Maybe soon enough, people out at sea would want to order pizza. So there you go. Yeah. You have room for expansion.
Yeah. That would be a good idea.
Yeah. No, thanks for that explanation. That puts things into perspective really nicely for all the naysayers, the many people who are just anti-technology in general, and drones just happen to be one of their interests. Hopefully you've laid a lot of that to rest with your explanations. If we may digress just a little bit as we get to the end of this, some of the people, actually majority of the people watching this, are new to the tech field and looking to build a thriving career in the tech industry. Drones and aircraft might be one of them. So far in your career, is there like a huge one big mistake you made that you would advise anyone venturing out down this same route not to make the same mistake?
The thing is, like, I didn't spend too much time in a traditional career because I worked in Airbus for 3 years, and then I went to start my company, and I've been doing that for like 10 years almost now. So I think most of my mistakes are about building the company, not necessarily the career. I'm actually relatively happy with the choices I made in my career, in the sense that I guess I was lucky from very early to be super passionate about something. And because of that, it always made it clear what I wanted, what I should be doing, because I was just following that passion. And so it was like, I studied aerospace engineering, and then went to get the job I wanted in Airbus, and then I worked really hard to get it, and was very persistent and got it, and then moved on. But I think maybe I can just give an advice based on when we hire new people now, what do I look for? And I think the main thing that made people stand out now is when you're proactive at doing stuff on the side. I personally almost don't care if you have a degree. Like, we have people on our team that are doing the same job as someone with a master's, and they haven't gone to university at all. And that's because specifically in our space, in the drone space, I said it before, it's a very young industry, and you can very quickly pick stuff up about the industry by spending the weekend building a drone. Like, you can buy an autopilot nowadays for probably like 10, 15 pounds. You can buy the parts to build your own drone. Maybe, maybe you get to 100 pounds. So, for some people, that's a good amount of money. But with that, you can actually build a drone from scratch. And most students in university don't take the time to do this. And so for us, they're not that interesting because it's not super valuable if you've just gone to lectures and got your grades. Like, what we want is people that have gotten their hands dirty and have actually built stuff and troubleshooted problems and things, because that's what we do most of the time. So it's not a mistake I've made, but that's like the advice I would give in general is like, if you're passionate about, figure out what you're passionate about and then go on, like, be humble and go build things yourself in that field.
I agree. I think that's an invaluable piece of advice. So essentially you would want them to test out their skills to some extent, to have something to show, not just go apply with a CV written out on a paper. They should have some work, something they've built before they try to apply or to join some companies in the aircraft business, right? That's it.
I think, yeah, it is having it's also when you are in but we're a startup, so we need people that can figure out what needs to be done by themselves. It's not like, you have a detailed list of here are the 3 tasks you need to do today. It's kind of like, here is the broad direction of where we're going together as a company, contribute to that, and then you need to figure it out. That's the type of skills you learn when you're doing home projects on the side. It's like, oh, I'm gonna connect my I'm just making something up, I'm gonna connect my toasters to the internet so I can remotely control it or whatever. Like, this is a completely stupid project, but it's like, okay, I'm gonna pick up a board and I'm gonna learn the software and the electronics to connect it to my toaster and be able to control it remotely so I can do bread on command or whatever. Like, doing those types of projects where you need to figure that out by yourself and build those things make you massively stand out, and it teaches you skills that are not skills that you learn necessarily at university. The other thing as well is it shows how self-motivated you can be. And that's one of the things we look for as well, is like, what are the other things outside of your job or your studies that you've done? So, you've done maybe stuff in sports and you're super passionate about some other hobby. I think these things are also very important. In some way, I think nowadays more than just what degree you have.
I couldn't agree more. I mean, nothing beats empirical knowledge. The universities and the formal qualifications, they are good to have, but ultimately learning this on the streets, in the field, surpasses anything else. So yeah, thanks. That explains and put things into perspective nicely. Just before we wrap this up, Mathieu, anything else about the drones you would like to share with the public? Or if we have touched on everything you had in your mind this afternoon, that's equally fine.
Yeah, no, I think that's it. It was a really good discussion, and I think with your guidance, we covered most of the things. So yeah, nothing specific to add. I mean, if people are interested in what we do, you can just check out our website. It's www.marble.aero. Reach out on LinkedIn, follow our contents in general. And yeah, there will be most of the other information will be there.
Great. Thanks for sharing that. I was going to ask how they could find you online. Nice drone, by the way, the one you have behind you. It looks like it has 2 parts to it. There's a front part and a back part. Really cool looking, military looking thing, which is quite cool. Mathieu, it was a pleasure having you on this episode. Hopefully you would come back in the near future if you've made some progress with the company, with what you're working on, just to update us on how the drone industry is moving along. I myself, I know I've learned a lot on this call regarding drones, and I'm sure there's still quite a lot to learn if we had more time. So thank you.
Thanks. I appreciate it, Newton. It was a great time having a chat with you.
Yeah. On that note, we bring this episode to an end. Thank you for watching. Don't forget to like, share, subscribe, and all that good stuff that follows. Until the next episode, cheers.